All right, it's time to take a look at a few more trouble questions from the most recent assignment. The first question I want to take a look at is number 81. In this diagram, a lot of stuff, and most of this stuff right here is fairly self-explanatory, and it's given. I think probably the most important part here is that AC is parallel to DF. Now, if I was going to trace over that just to kind of make this more obvious, we're saying that this line segment is parallel to this line segment. Now, I think the most important part of information here that's maybe not specifically drawn or shown is that this right here could act as our transversal. So if you remember from geometry, we talked about special types of angles. If this angle right here is 35, this angle down here is also 35 degrees because they're alternate interior angles. So basically, we've got this angle down here in the bottom is congruent to this angle up here, and they are both 35 degrees. Now, using properties of isosceles triangles, if this is 35 and this is 35, the base angles have to be congruent. So therefore, this angle over here is also 35. So angles opposite congruent sides are going to be equal. So we have 35 here, alternate interior. Isosceles triangle base angles are equal, so this angle here is 35. So basically what I have, if I was just going to take this part of the diagram and draw it separate, is I have a straight line that's 180 degrees. And I have a piece of this broke off right here that's 35 degrees. So therefore, to find this side, which is what we're asked to find, we're just going to take 180. We're going to subtract the 35 degree angle we found, and we're going to end up with H, 145 degrees. The next one, number 84, is another problem you had questions on. In this problem, it says that we're going to buy a notebook for $2.50. So our cost to buy 9 of these is going to be 9 times that $2.50. If you multiply 9 by 250, that's our cost before tax. It comes out to be $22.50. Now, you have to understand that by buying 9, we got 1 free. So actually, we ended up with 10 notebooks. So if we're looking for the average cost before tax, we just need to take $22.50 divided by 10. That easily divides using some of our shortcuts as $2.25 per notebook before tax. So getting that free notebook in here gives us 10. Obviously, the free one helps lower this average. So the average cost per notebook is $2.25. The second to last problem I want to look at is number 85. This problem is probably most confusing because of this little x1. But all this is saying is, what would this expression right here be equal to for any value of x? Well, we have to remember that 3x plus 1 inside parentheses squared actually means we're going to take 3x plus 1 times itself. An exponent of 2 tells us we multiply whatever is inside parentheses by itself. So in order to multiply this, we actually have to do some foiling. So we have that times that is 9x squared. That times that is 3x. This times this is also 3x. And of course, 1 times 1 is 1. We combine like terms to end up with 9x squared plus 6x plus 1. The most common mistake here is that students think that they can take this particular exponent right here, the squared, and just distribute it in here. So they'll say we end up with things like 9, because 3 squared is 9, x squared plus 1 squared, which is 1. So this is a very common answer that students will make. You'll notice that that is actually option H. That is not correct. Be very, very careful of that. The last problem I want to take a look at is number 89. This is a system of equations. The first thing I would do in this system is to solve for y. So in both of these, we have to divide by 3 on both sides. So we'll divide by 3, divide by 3. We'll actually do the same thing here. We'll divide that by 3, divide that by 3. When we do that, we end up with y equals negative 2/3 x plus 8/3 in the first equation. And the second equation right here is going to end up being y equals positive 2/3 x plus 8/3. So the question is simply asking, what happens to these two lines, or how do these two lines graph in the coordinate plane? Well, we can very quickly look at this and we can see that the slope of these two lines is different. This has a negative slope, it's going to be going downhill. This line here has a positive slope, so it's going to be going uphill. So we have a negative slope and a positive slope. The y-intercept is indeed the same. So basically what that means is that it's going to cross the y-axis. If this is the y-axis, it's going to cross the y-axis at the same point. So because the y-intercept is same, it's crossing the y-axis at the same, but the slope is different, so one is going uphill, one is going downhill. So if we're going to look at these, what type of lines would we have here? Well, we're not going to have a single line because these are both different equations. We're not going to have a single line with positive slope again because they're different equations. We're not going to have two parallel lines because the slopes are different. We're not going to have two parallel lines again because the slopes are different. So that leaves two distinct intersecting lines, and there's just a very quick sketch of roughly what that would look like right there.